Good morning, geometry. This is 11.3, page 737. We can make this really simple if you would like. Why don't you write this down with me? That the perimeter 1 is to perimeter 2, as side 1 is to side 2. In fact, I'm going to write it a little differently. Side 1 is to side 2, as perimeter 1 is to perimeter 2. You got that written down? Now, the areas of the same polygon, similar polygons that is area 1 is to area 2 as side 1 squared is to side 2 squared, as perimeter 1 squared is to perimeter 2 squared. Now you can take the square root of all that, and you can take the square root of area 1 is to the square root of area 2 as side 1 is to side 2 as perimeter 1 is to perimeter 2. So why don't we just stick that one on the top one, and that way I can erase that. So let's go ahead and say that equals the square root of area 1 over the square root of area 2. These are just simple proportions. All we're going to do in solving these problems is plug and chug. It's very simple. 11.3 is a simple solution. Just got to draw the picture, see what they gave you, and pick the right formula to plug and chug. They're going to give you 3 things, and you're going to give them the 4th. What do you mean? Well, if they give you 2 sides and a perimeter, then you're going to give them the other perimeter. If they give you 2 perimeters and an area, then you're going to give them the other area. They're going to give you 3 things, and you're going to have to give them the 4th. So in example 1, we've got red to blue, okay? We've got a little triangle there. Now, how do you know that 8 corresponds to 12? How do you know that those 2 sides correspond? Well, you guys know how to write these similarity statements already. You're so good at it. If you look at the 8, it's between B and C. Now look at the similarity statement. Triangle ABC is similar to triangle DEF. And they said that at the beginning of the problem. So it's very simple that BC, there it is, corresponds to EF. And what do they want to know on the part A? They want to know the ratio of the perimeters. They want to know this ratio right here. What's a ratio? It's a fraction. So if they want that ratio right there, what if you were able then to give them this ratio? So the ratio of the perimeters is very simple. It's red to blue. They want to go red to blue. It's 8 to 12. The answer to part A is 8 to 12. Because that's a ratio, a fraction. Go ahead and reduce it. Take 4 out of there twice, take 4 out of there 3 times. The answer will be 2/3. Okay, and then B wants to know what is the ratio of the areas. Oh, they wanted the ratio of the perimeters. Okay, guess what? The ratio of the perimeters is the same as the ratio of the sides. Okay, that's the ratio of the perimeters or the sides. And then you just square it. That is the ratio. Now 2 squared is 4, and 3 squared is 9. So there's the answer. Get that. 4 over 9 is the ratio of the areas. Because it's the square of the perimeters over the perimeters, or the square of the sides over the sides. And so 4 over 9. Next page. Of course, you can write that also as 4 to 9. You can write that as 2 to 3. That's the same thing, expressing a ratio. All right, let's go to the next page. Example 2. Example 2 is we got a ratio of sides of 14 to 10. If you go den to bedroom, 14 to 10. We'll go bedroom. We're going to go den over bedroom. Okay, so the sides are 14 to 10. And what does it say there? The carpet for the bedroom costs $225 and it's sold by the square foot. So basically 225 bucks represents the area, the square feet. So it's 225 for the bedroom, that's the 10. Okay, so that's going to equal, let's see, side over side is equal to square root of area 1 over the square root of area 2. And it's den over bedroom, and 225 was the bedroom. So we're going to go 225. That's the cost, but it represents the area. And so we're looking for that right there. The cost, we're looking for the cost of the deal. Okay, well, we can do this. We could have also used this right here. I think that's what the book did. So why don't we do it that way? So we're going to go ahead and square this. And that way these aren't squared. Den to bedroom. So what is the side to the den? 14. Bedroom is 10. And we're going to have to square those things. Now, I believe what they did was they went ahead and reduced that to 7 over 5. It doesn't matter. The simple proportion is going to work out either way. So we can go 7 over 5 like they did, because that's the ratio of the sides. And so we'll go ahead and 7 squared is 49, 5 squared is 25, and that equals x over 225. Cross multiply, 25 times x equals 49 times 225. And so you're going to divide by 25. Divide by 25. And so x is going to equal 441. When you take that times that divided by that, it's going to get 441. And it represents area, which represents the money spent. Okay, let's look at example 3, ratio of areas. Okay, so we got a rectangle, big rectangle, and then we got a little rectangle. That's nice. Okay, and this is 15 and 10. And this is question mark. So the area here is 15 times 10, which is 150 square inches. And the area here they gave us is 96 square inches. And this is a side, and that's a side, and this is an area, and that's an area. Now we're going to find a formula. A side, an area, and an area. So that looks good. So how about if we go, well, that x, and we're going to go 10, we're going to go big to little. 10 squared is to x squared as, come back over here, 150 is to 96. Okay, big, little, big, little. Big over little, boom, boom. Big over little, don't forget to square. Okay, so now it's just a matter of finishing it up. X squared, 150x squared equals 10 squared, which is 100 times 96, which should be 9600, and divide by 150. And after you divide by 150, take the square root of both sides. And so once you do that, x is by itself, and you're going to get 8 inches. And since this is inches, this will be in inches. Okay, that's 11 minutes. Can you handle another example problem? Let's give it a swing. I'm going to see if I can knock this one out. First of all, on the top of 739, you can see that two regular polygons with the same number of sides. If they're regular polygons, they have the same angles and they're convex. You remember all that stuff? And then they have proportional sides. And any two circles are similar. These two are similar polygons. They're hexagons and so on. Okay, so example 4 says, the floor of a gazebo shown is a regular octagon. So you can see the gazebo is an octagon. The way I draw octagons is like this, and then I bulge it out and come down and bulge it in. And I bulge it out and come down and then I bulge it in. And it says here, you got a little model. So we'll draw this little model, and we'll draw that little model, and we'll bulge it out. Oop, too much. Out, down, in. Out, down, in. Okay, good. Now we got two octagons. Each side of the floor is 8 feet, and the area is about 309. So they gave me this. Area is 309, and each side is 8 feet. This is square feet. Okay, so if it's a octagon, that means there's 8 sides. Okay, so do you know the perimeter? 8 times 8 is 64. Perimeter is 64 feet, and the area is 309. It looks like we're going to be comparing perimeters with areas. And the little one, it says the perimeter of the floor is 24 inches. Well, the perimeter is like 24 inches, like 2 feet, right? 24 divided by 12. So the perimeter is 2 feet over here. 4 inches. And what does it want to know? It wants to find the area of the little model. Okay, area equals X. So we got areas and perimeters. So which one are we going to use? Going to use this. Area is to area as perimeter squared is to perimeter 2 squared. Okay, we can do that. All right, so let's plug and show. Area is 309. And area over here is X. Perimeter over here is 64. Perimeter over there is 2. Cross multiply, 64 squared times X equals, I can do 2 squared in my head, 4 times 309. Then divide by 64 squared. And you're going to get X equals whatever that is. And they say it is 0.302 feet squared. But what did it want the area of the floor of the model? They wanted it in square inches. So you got to take that and convert it into square inches. Do you know how to do that? Of course you do. If you had Mrs. Gill and she taught you how to do unit cancellation, you need to know this before you come to my chemistry class. I want to convert square feet into square inches. So I do 2 of these. Feet go down here, so it'll cancel. Feet go down there again, because feet times feet is square feet. So can you see that you're canceling that? And 1 foot is the same as 12 inches. And 1 foot is the same as 12 inches. And so what we're going to do here is we're going to take that times that times that, and that will equal, they say, 43.5 square inches. You can see if this is easy, it's just plug and shove. It's 16 minutes. I'm very sorry I ran a little over, but it's good to see you all, kind of. All right, so on Wednesday, you're going to do page 740, 3 to 13 odds. And then on Thursday, we're going to have a quiz. And it'll be one of those deals where you fill out a blank quiz. You know, you've worked the problem, and then you come up with an answer, and you choose A, B, C, or D. And then on Friday, we'll have a test. And that would be over 11.1, 11.3. 11.1 to 11.3. Quiz on Thursday, test on Friday. See ya. Open book, always open book, open notes, everything, you know.